In this lesson, we're going to talk about relations in function, and we're really going to focus our attention on relations and manipulating a relation into different forms. So first of all, what is a relation? It's a collection of ordered pairs containing x values and their corresponding y values. And a function is a special type of relationship where each x value, which we also call an input, has a single output called the y value. So let's go ahead and look at this example here below. I have this thing called a rule, and it should look familiar to you from our sloped section. This is called an equation in slope-intercept form. And you can see that my equation or my rule is called y equals x plus 2. Now what I want to do here is I want to take my equation, my rule, and I want to put it into a table of values. And then I want to take that table of values and put it on a coordinate plane. So let's go ahead and do that. I have the rule y equals x plus 2, and I know that that rule creates a line. But I need the coordinates of the line in order to graph it. So the first thing to know about this rule is that there are an infinite number of coordinates on this line and that make up this equation. So basically, what we're going to show in the table of values is just 4 of those coordinate points. I'll show you what that looks like in a second. Okay, let's look at the table of values. I want to take that rule and I want to create x values and y values. The way that I do that is I'm going to choose x values or input values, and I can choose any numbers that I want. I usually like to stick with nice easy numbers, small numbers such as 2. We'll start there. So what I want to do with my x value is I want to input it into my rule. So really what I have is y is equal to 2 plus 2. Which would give me a 4. 4 is called my y value or my output value. That's what the function puts out. Let's choose another x value. I'm going to choose the x value 1. So if I put 1 into my x value here, I'm going to have y equals 1 plus 2. And 1 plus 2 is going to give me 3, and that's my y output. All right, I'm going to go ahead and choose another easy number. I'm going to choose 0. So if I say y equals 0 plus 2, well, 0 plus 2 is 2, and 2 is going to be my output. And I usually like to pick a couple positive numbers. I always like to use 0 as an output value, and I also an x input value, and I also like to use a negative number. So I'm just going to choose -1 for this example. If I put -1 in there, I'm going to get y equals -1 plus 2. -1 plus 2 is 1. Now, like I said, there are an infinite number of x values that I could put into this rule to get out an infinite number of output values or y values. But for right now, I just wanted to choose 4. Now let's go ahead and graph it. A table of values is another type of relation. You can see that just like in a coordinate, I'm going to put a coordinate down here. A coordinate has an x value and a y value, just like in our table of values. So really what I have here, I'm going to use this as an example, 2, 4 is a coordinate that I'm going to graph on my coordinate plane. So I'm going to go ahead and do that. I'm going to start at my origin. I'm going to go to the right 2. And I'm going to go up 4. And this is why we learned the coordinate plane before we learned how to graph relations and functions. My next coordinate that I see is 1, 3. So I'm going to start at my origin. I'm going to go to the right 1, and I'm going to go up 3. My next coordinate is 0, 2. So I'm going to start at my origin. I'm not going to go left or right, but I'm going to go up 2. You're probably noticing that my slope is the same for this, and that's pretty common. All right, my last one is -1, 1. Okay, now I could continue adding x and y adding x coordinates that have a corresponding y coordinate, but for right now, I'm just going to live with these 4 that I have here. But one thing about this is if I have a rule like y equals x plus 2, that means that these dots right here have to be connected. And not only are they going to be connected together, but they're also going to be connected just like this. And on either side of the line is going to be arrows saying that there's an infinite number of x values and there's an infinite number of y values, creating a line. And that is how you graph a function rule. Let's go ahead and look at another example. Okay, so now I have a rule of y equals 3x. So I'm going to go ahead and choose my x values. Again, I can choose any x values that I like. I personally like sticking with small numbers. So this time I'm going to start with the number -2. I just picked that because it was a nice small number. So I'm going to substitute that x into this x right here. So y equals 3 times -2. 3 times -2 is -6. And actually that wasn't the best example to start with because it goes off of my coordinate plane here. So I'm actually going to choose another one just for the purpose of the examples. You'll see why in a second. Let's choose a smaller number just so it fits on the coordinate plane that I have here. Let's go ahead and choose 1 or -1. So if I do that, 3 times -1 is going to give me -3. That's much better. It's going to fit on my coordinate plane. All right, let's go ahead and choose 0. So I have y equals 3 times 0, which is going to give me 0. And then I have, let's go ahead and choose 1. So y equals 3 times 1, which is going to give me 3. And then I am going to end up having to be off my coordinate plane, but that'll be okay. Y equals 3 times 2, which is going to give me 6. Okay, so let's go ahead and plot my points. My first coordinate is that -1, 3. So -1, 3, if I plot that, it's going to look like right here. 0, 0, that's my origin. 1, 3, it's going to be right here. And my other coordinate, 2, 6, is going to look like right here, but that's okay. I'm a little off the graph. That'll be fine. And I'm going to, because it's a function rule, like this right here, I am going to draw a nice straight line through my coordinates with arrows at the end of my line. Now, what those arrows mean are that this line is going to continue on and on and on in both directions forever because there's always going to be an x value and there's always going to be a y value for this function. Okay. Now, let's see if we can add one more thing into the mix, a sentence. Now, this is kind of the easy part because we've already done this in the previous units. So I see that my rule is y equals x plus 4. Now, a sentence, what that is I want to translate my rule from an algebraic equation into words. So if I were to do that, I would have y. Remember, equals means is, so y is, and I'm going to say a number plus 4. I just translated it into words. Now what I'm going to do is what I've been doing all along. I'm going to go ahead and take my rule and I'm going to put it into a table of values. So if I did that, I'm going to choose some nice numbers. I like to start in the negatives personally. I'm going to start with -2. So I'm going to take that -2 and I'm going to substitute it in for this x. So y equals -2 plus 4. -2 plus 4 is going to give me 2. I'm going to say -1. So y equals -1 plus 4. It's going to give me 3. I'm going to choose 0. Y equals 0 plus 4. And that's going to be 4. And my last one is going to be a 1. And I'm going to say y equals 1 plus 4, which is going to be an output of 5. Okay, let's go ahead and graph them. -2, 2. -1, 3. 0, 4. And 1, 5. Notice how it creates a line. If your points do not create a line, then you must have done something wrong with your addition when you were putting the x value into your rule. So I'm going to go ahead and put a straight line reaching from one side of the coordinate plane to the other with an arrow on each end. And that represents my rule as a graph. Now the next one's a little different because this time I give you the sentence. And you want to fill in what is the rule, what's the table of values, and then what's the graph. So personally, I like to go from the sentence to the rule. So let's go ahead and translate this sentence. I have y is equal to, right? Is equal to is going to be our equal sign. Double, that's going to be times 2, and then a number x. So when I translate this, my rule is going to be y equals 2x. Now that I have my rule, I can go and generate my table of values. So I'm going to start with -2. So my input is -2, so y is equal to 2 times -2. That's going to give me -4. My next output value, I'm just going to do -1. I like to work with nice small numbers. So 2 times that input of -1 gives me an output of -2. I'm going to keep going, and 0. Y equals 2 times 0, which gives me 0, so it's going to go through the origin. And my last one, I'm going to choose x as 1, so y equals 2 times 1, and 2 times 1 is 2. So I've created my table of values. Let's go ahead and plot those. -2, -4, -1, -2, 0, 0, and 1, 2. Notice how they're all in a nice straight line. I'm going to go ahead and connect those dots with a straight line with arrows at the end. So the first one I was given my rule first, and I had to find the other 3. The second one I was given a sentence, and I had to find the other 3. Now you can imagine what the next ones are going to be. I'm given a table of values. All right, now we're going to have to kind of reach back into what we learned in the last section on slope. So if I have a table of values, I know that I can put it on a graph. So let's go ahead and do that. -4, -2 is my first coordinate. So -4, -2. -2, -1, 0, 0, and 2, 1. I'm going to go ahead and connect those dots with my line and my arrows, and I have my graph. Now, this is the tricky part. Now we have to think back to the slope unit. Remember when we created an equation in the slope-intercept form, or y equals mx plus b? I need to figure out what my m and what my b are for this line. My m is my rise or my run. So if I go from this point to this point, I'm going to rise 1 and run 2. So 1 over 2. My y-intercept is where my graph crosses my y-axis. You can see that it crosses it at the origin. So I'm going to translate that into slope-intercept form. Y equals 1/2 x plus 0. But we don't actually have to write plus 0, so my final slope-intercept form, or my rule, is going to be y equals 1/2 x. Okay, let's create a sentence now. Y is, let's say, half of a number, because that's what this rule is stating. All right, now we have a graph. Let's go from the graph, and we have to create a rule, a sentence, and a table of values. So lots of things we can do here, but personally, I think we could start with the rule since we just came off from doing that. So let's go ahead and figure out what my slope and my y-intercept are of this graph. So I'm going to pick 2 points, and my rise is going to be 2, and my run is going to be 2, which simplifies to 1. My y-intercept is going to be right here, which is 1. So if I were to create a rule, my rule is going to be y equals 1x plus 1. And I know that I don't need to recognize that 1 in front of my x, so I'm just going to say y equals x plus 1. Okay, my sentence. Y is, let's throw a than in there. Let's say 1 more than. I like that. a number. Now my table of values can come from two different places. It can come from my rule or it can come from my graph. Most people like to get it right from the graph, and they're just by listing coordinates. So let's go list some coordinates. I'm going to go ahead and change my pen color to show you this. Let's go ahead and choose this coordinate here. That coordinate is 1, 2. I'm going to go ahead and choose this coordinate here. That's going to be 2, 3. I'm going to choose this coordinate down here, which is -2, -1. And I'm going to choose my y-intercept, which is going to be 0, 1. So now I've been transferring back and forth from the different types of relations. All right, and that is the end of our section on functions and relations.